Hightower. I've been doing this for over 6 years now, and the goal of this is to bring all the IoT expertise, domain people together so that we can find out about each other. Because Internet of Things is about devices and connectivity in the back end. And a lot of times we don't know each other. So I'm trying to bring everybody together, have a chance to find out what expertise and capabilities and knowledge is available so we can share and start helping each other. Mobeen, we'll turn it over to you and introduce yourself.
So my name is Mobeen Khan. I've been to a couple of these things before, but with a different badge. I used to work at AT&T before with Eric as well, and I used to manage AT&T software, IoT software, and applications business. While I was there, we worked on a few. Many of you may know our innovation centers, or AT&T's innovation centers called Foundries. In those, we incubated new design ideas, worked with startups. One of the ideas that we were throwing around is how to make it really easy for developers to build IoT solutions. Today, anybody who's built, you have to go through 10 different places and 5 different SDKs and make it really, really complex and complicated and costly. So we incubated a bunch of SDKs and ideas over the last 3-4 years. And one of those was working with Ray Ozzie, who is a software entrepreneur, very well-known guy, and sits on the advisory board for AT&T. And that project turned into what we're here to talk about, which is this 32 millimeter by 35 millimeter device called Notecard. And this comes packaged with all kinds of stuff, 2 lines of code, and embedded cellular connectivity for 10 years and 135 years. So put that in your HVAC, coffee maker, what have you, and you have cellular IoT instantly. Brandon will talk about that. I'll pass this on to him. He leads our DevX and has joined us. I don't know how many months it's been, but it's been a long time now in our short history of Blues Wireless. Blues Wireless is based out of Boston, Massachusetts, but a few of us are here in Texas. I'm here in Dallas. Brandon is in Austin, Texas, and we're a startup team. We're next week, I think we're going to a commercial launch. We've been sort of in a stealth mode, working with about 30 or 40 beta customers. So you'll hear all about the Notecard and Blues Wireless in the next few minutes, and I'll be hanging around afterwards if you want to have a discussion. If you want to reach me directly, it's mobeen.khan@blues.com, and I'm sure somewhere in the email will be out there.
Is it blues.com or blues.io?
The website is blues.io.
Oh, okay.
The email addresses are blues.com.
Gotcha.
Okay. Thank you.
And
Passing it back to Brandon, start of the show.
get rolling. So thanks again, everyone, for being here today. Thanks, Ed, for the invitation. I always enjoy speaking to this group. This is, I think, the second or third time spoken, but it's been a couple of years now. First time virtually. But what I wanted to spend some time talking about today is a lot of what Mobeen just teed up and introduced, which is a new vision for the IoT from the team at Blues Wireless. And we are just days away from a public launch, but you all in this group and virtually online are getting the first preview of what we've been working on as a company for the last couple of years. So by way of intros, I'll talk about myself very briefly. I am the Director of Developer Experience at Blues Wireless. I have been at the company for 6 months, actually 6 months as of 2 days ago. So it has been a lot of fun. I've enjoyed working with the team, and we've got some really exciting stuff coming. But my job is to ensure that our developers have really everything that they need to be successful with our products. Previously, I was the head of DevRel at Particle, and I have 21 years of experience as an engineer, product manager, and 6 years in the IoT space. So here's my plan for today. I want to spend really no more than 45 minutes or so talking about our products, and then leave 15 minutes or so for Q&A. And I know there's an online roundtable that's going to happen at the end as well, and I'll stick around for that. But I also want to sprinkle in a couple of demos so that you can actually see our products in action. But before I get into who we are and what we do, I did want to spend a few minutes talking about why we exist. And as you all as IoT professionals and practitioners are going to be familiar with a lot of these things, but I want to set the frame by talking about really the challenges in the IoT space. So I've spent the better part of the last decade really focused on developer-focused software and hardware. And every product that I've worked on in that time has existed to help developers overcome or address problems in their particular world. Some of that has been very software specific, but in the IoT space and in the cellular world, I like to call these I call these problems the strings of wireless IoT. They are things that developers often cannot control or that make their lives difficult. They slow them down, cut off choice, or provide unnecessary duplication of effort. The most pernicious ones that I've observed in the IoT are difficult to program modems, too narrow or too wide guardrails, pitfalls with device lifecycle management. For many solutions, the security is just not baked in. And then finally, that there's no simple path from prototype to production. And I'll spend a few moments talking about each of those. First, let's talk about modems. Now, if you've ever had to work directly with a cellular or a Wi-Fi modem, you might be familiar with the Hayes command set or AT commands. This style of interaction has been around since the early 80s with the first modems, and it is still in use in a lot of embedded modules. Now, for many developers, especially somebody like myself, AT commands are cryptic and inaccessible. They are non-intuitive and they can differ from one module, from one vendor to the next. It's a very painful way to add connectivity to your application. To combat the difficulty of programming radios, many IoT vendors tend to put up guardrails that are designed to help developers. Many create narrow guardrails and abstract away the complexity into developer-friendly APIs. The problem is that they also force you to adopt their host microcontroller, their RTOS, and even a particular programming language. And as nice as it is to get an abstraction away from those AT commands, it is off-putting to developers to take away that much choice in exchange. Now, other vendors give you wide guardrails. They sell you only a SIM or a piece of hardware that requires you to furnish your own SIM and plan. This approach has certainly brought down the cost of IoT or M2M data plans, but it swings too far in the other direction. You get cheap connectivity, but developers are left to build up the rest of the solution stack themselves. The developer ends up with the equivalent of a writer's block or blank page syndrome because there's just so much to choose. And in both of these cases, developers are just left with either too much choice or too little choice, and it can be very challenging to get past that. Finally, next, pitfalls with device lifecycle management. And the reality is that most IoT products don't really follow a happy path where they spend no time on the shelf or deployed in the field immediately and are used forever and ever without end. Instead, all IoT devices really go through a pretty consistent life cycle, and their duration at each stage varies, but all of them really tend to experience this set of activities. They start an inventory at the manufacturer via distribution where they sit idle and unactivated. They're activated when they're first used. They're used for a while, but then there's a period where they fall into disuse, but the device is still online and potentially even still accruing fees. You can imagine in this case a Kindle that you only use on vacation, right? Maybe you only use it in the summer to read at the beach. The rest of the year it kind of tends to sit idle, but it's still connected. It's still an active device. Then there's a period of temporary breakage. It can often take months before the issue is identified and fixed. Then there's a recommissioning after fixing, and then a period where a device is decommissioned permanently. Now, the challenge in the cellular IoT space is that each of these phases in the device lifecycle introduces carrier fees and transaction costs that can be difficult to plan and budget for. What that means is that when most developers look at a cellular IoT device especially, they really don't know what its true cost is just by looking at what's on the tin. So next is security, and something that's often really not considered by a lot of developers during prototyping, and which many providers don't bake into their products. But key and certificate management is an essential part of any IoT solution, even at the pilot stage and definitely well beyond. All IoT platforms now require TLS, and in the absence of more secure approaches, a lot of developers are forced to store keys in firmware in order to work with cloud services. And for devices themselves, the provisioning process is often quite painful, leaving developers to muddle through at the last minute, right before they're at the 11th hour trying to get that pilot deployed. Finally, there is the string of the prototype and production disconnect. Now, in one sense, I think we're all quite grateful. I'm personally grateful that prototyping is as accessible as it is today, thanks to companies like Arduino, Adafruit, SparkFun, and the Raspberry Pi Foundation. But most of the devices produced by these companies have been so focused on the maker market that they've never been taken seriously for production use. Now, IoT engineers will gladly use these accessible tools to prove an idea at the prototype stage, but we often see those as just throwaways, right? We build the prototype and then we feel like we know we're going to start over again with a real piece of hardware or a real custom PCB, right? And then finally, even after deployment, improving the device or fixing it or creating or pushing updates via firmware can be a challenge with a lot of systems. And there's a lot of different factors that I talked about here, but when taken together, the strings of wireless IoT create an environment for developers where complexity rules. From the jump, the path of selecting a board, to building a prototype, to developing and scaling a pilot is filled with hurdles and roadblocks that make it hard for many initiatives to succeed. So when I think about complexity, I tend to think of a quote from our founder, Ray Ozzie. And it's something that he said long before setting out to build the company, but which applies very much to the IoT of the present, and I'm sure it's one that many of you will identify with. And that quote is, "Complexity kills. It sucks the life out of developers. It makes products difficult to plan, build, and test." Now, I'm guessing many of you have heard that before in some fashion, and it should come as no surprise then that Ray was motivated to start Blues Wireless after experiencing a lot of the pain of building an IoT solution firsthand. So Ray is on the board of an environmental data nonprofit named Safecast, which was formed in the wake of the Fukushima Daiichi nuclear power plant meltdown in 2011. Now, the founders of Safecast wanted to create a way to collect and share radiation data from the exclusion zone in Fukushima, and the effort has since expanded to be one of the largest citizen science projects in the world. Their current goal is to cover every road and location worldwide, including dangerous and hard to visit places such as exclusion zones and waste sites and all reactors worldwide. And as a part of his involvement with Safecast, Ray set out to build an IoT device that could collect air quality data from remote or inaccessible locations and operate for a year or more on a single battery. And along the way, he experienced many of the strings that I mentioned before. So Ray set out to solve these problems, not just for himself and for Safecast, but for IoT developers everywhere. And over the last 2+ years, he and our small team have been working to create a set of products that give developers everywhere the ability to easily build IoT solutions with no strings attached. Those products are low-power prepaid cellular IoT modules, a set of developer-ready carrier boards, and finally, a secure console for managing devices, data, and integrations with other cloud applications. And so for the rest of my time today, I want to share a bit more about each of these three and sort of how they fit together into our solution set. First, let's talk about the Notecard, the device that Mobeen just showed off, and I'll show you a close-up view in a moment as well. This is the center of our universe. The Notecard is a device-to-cloud data pump that's ready to embed into new and existing applications. It includes a cellular and GPS GNSS module from QuickTel, an embedded SIM, an onboard Cortex M4 MCU, a secure element with pre-provisioned keys, an onboard accelerometer and temp sensor, and an M.2 edge connector. Now, as a developer personally who has worked with a number of IoT solutions, what I find most compelling about the Notecard is its cost, the fact that it's a low-power cellular device, and its API. Now, with cost, this is a really powerful one. Now, you recall earlier that one of the strings of the wireless IoT that I mentioned is the shadow cost, right? Developers pay for a device, and then you pay for its data, sometimes month to month, ad infinitum. With the Notecard, you get 10 years and 500 megs of data included with the cost of the device, and devices start at $49. You'll never get a monthly bill for SIM usage. One way to look at this is that the Notecard is the Kindle of cellular IoT. It's a device that you pay for, and its cellular cost, its connectivity cost is included in the price you pay for. It's on the tin. Now, we have narrowband and wideband versions of the Notecard with AT&T back support in over 135 countries. Depending on the Notecard you choose, we support narrowband IoT, LTE-M, Cat-M, and Cat1 networks. Now, compared to a lot of other IoT solutions out there, the Notecard is 10x less expensive for 10 years of cellular access. You pay $49 once, all the data is included, as opposed to paying for a device and then over a 10-year period paying for data metered out 1 month at a time. The note card is also a low power by default device, and this is a real challenge in the cellular IoT space, not to be overstated. One of the challenges that Ray had early on was the idea of building a low power cellular IoT product was very difficult with the state of technology of the day. This device was designed to operate in battery and solar environments, and it draws as little as 8 microamps when idle. That's less than the internal self-drain of most batteries. So for example, a standard 2000 milliamp LiPo has a self-drain of more than 75 microamps continuously. So you never have to worry about the note card being the thing that is the drag in your low power solution. It's also a secure device. All the keys and certificates are burned onto the onboard ST-Safe module at the factory, and all communications between the note card and our cloud service occur off the internet via our own managed VPN. So there is no key provisioning process. There's no cloud service that manages key expiration and exchanges. The keys are on the device when you get it from the factory. The note card module is also PTCRB in-product certified, so you can include it in your own product without having to re-certify the radio. Finally, and this, as a 20+ year developer, this is one of my favorite features. The note card speaks 100% JSON. It takes JSON requests and it returns JSON responses. No AT commands are required to turn on the radio, to perform a sync, to connect to GPS, anything. Everything that you can do with the note card is wrapped up in a JSON-based API that is simple and flexible. It's also documented extensively at our developer portal, along with complete guides, tutorials, and samples. And I will actually show off the dev portal. You can check this out yourself. Like Mobeen mentioned, we are very, very close to launch, but you can actually check out the developer portal at dev.blues.io today. Now, before I get to the demo, I did want to introduce a few key concepts that are important to how the note card works. Typically, a developer will interact with a note card from a host microcontroller or single board computer over a serial or I2C connection. Now, often that host will include sensors and actuators that need to be monitored or controlled remotely. To send sensor data to the note card, the host creates something called a note, and a note is a JSON object with key value pairs like temp and humidity in this example. Notes are created on the note card with a note.add request. This places the note in something called a note file, which is a collection of JSON notes. Then when the note card is ready to sync, it sends the note file to our Note Hub cloud service, which I'll talk more about in a little bit. But from here, your sensor data can be monitored and sent to third-party services. But the note card is bidirectional. It's also possible to send notes back to the note card and ultimately to your host, to your microcontroller or single board computer through the Note Hub. Much as with a note card, this starts by adding an inbound note to a note file, which when the note card then connects, Note Hub sends that note to the note card where your host can retrieve the note and take action. And I'll share a demo of that as well. So let's actually spend a few minutes and take a look at the note card API now. This is the thing that I want to start with, because I think this is a really important way of understanding how much easier it is to program the note card compared to just working directly with a cellular or Wi-Fi module via AT commands. So let me actually jump over and make sure that I am sharing the right. Oh, go back into sharing desktop. All right. So I mentioned before the our developer site, and this is basically for every developer starting with a note card, starting with the Blues wireless set of products. You'll end up at dev.blues.io, and this is where we actually have all of our docs, all of our reference material. We have an entire quick start that actually walks you through working with a device directly in sort of your first experience messing with the API. But we also have an in-browser console. We actually have an in-browser console called the Note Card Playground, which allows you to connect directly to the device without having to download any external tools or work with anything like that. So I have a note card that's on my desk, and I'll show you what that looks like here in a little bit for the next demo. But I have a note card on my desk, and it's actually connected via USB serial. And so all I need to do is click the connect button, and I can pair to the device from within the browser. And once I'm paired to the device, I can actually send commands to the browser itself. And so the first thing I'm going to do before sending any JSON commands is I'm going to turn on something called trace mode. And this is just a shorthand that will actually show me all of the interactions, everything that's happening behind the scenes, so that I can see how the note card is actually taking action based on the commands that I send. And when you're sending commands, the way that we actually have our API structured is using a noun verb structure as you operate on different aspects about the note card. And again, all of these things are documented in our developer site. But the first thing that most developers will do when they work with a note card is actually set its connection to the Note Hub, to our cloud service. And they'll do so by issuing a request called hub.set and then specifying the name of their product, or product UID. A product UID is effectively the way that you associate a note card to a product or project that you have specified on the Note Hub side. There is no complicated claiming process. The note card is not tied to a user account that you have to transfer to somebody else. It is associated directly to a product that you have created. So the way that I specify that is I will actually send in this hub.set request, and you'll notice, again, this is just JSON. Let me copy in the name of my product UID. The product UID is just a string. That's a string that is globally unique, that's unique to you. So I can set that product UID, and once I've done that, you'll see there's some things that are happening behind the scenes. The note card is actually going to connect to the Note Hub and effectively start a cellular connection and associate my device, my note card, with this project. You'll notice that this is where the AT commands are happening, right? I didn't have to type in AT QCFG. I didn't have to pass in an APN. Didn't have to do any of that, and it actually all happened pretty quickly. I've already, as you watch these things stream through, I'm already getting a TLS cert from the server, getting a connection to the domain, and syncs are actually taking place. So that's one of the first commands that you'll make. But really, time in and time out, what most developers are going to be doing is you're going to add sensor data. I talked about this before. You're going to use a note.add request to basically take readings as you're working with sensors, as you're working with devices, and add those to the note card. So I'm going to do a note.add request. And note.add, it's a JSON object that has really only one required parameter, and that is a body. And that's some sort of JSON object. I'm just going to do a very simple JSON object, foobar, canonical developer example, and I'll add that note. And I get a response from the note card saying, okay, this has been added. Now I can actually, it is ready. It's in the queue, ready to sync to the note card. Now, one of the ways that I can initiate a sync from code, I can actually specify the way the device is synced using the API to set up rules to say sync every hour, outbound, inbound, sync periodically, or I can say sync every time that I actually add a note. But I can also manually perform a sync via the API. And again, in the future, when I get to adding my host MCU for this in code, I can call hub.sync to say, okay, now it's time, reconnect, start a new session with the Note Hub, and actually add this device or add this note back into the back end. So that is a very quick look at at sort of the note card API. But I can also actually get, actually, let me show you one more thing, because I can get information from the note card about its current state, not just adding things, but also seeing sort of how its connection is. What sort of information I can get about where the network is located, my signal strength, and whatever. So I can do card.wireless, which actually gives you the status of the network, my bars count. So I've got 2 bars right now. It'll show you my RSSI values and give you information about when the network connection was last updated. So the API is very extensive and is documented completely. Everything from how you work with a note card to how you add notes to interacting with a Note Hub to how you actually perform device firmware updates and all that kind of stuff. All of these things are abstracted in. It's 100% JSON. JSON to the note card, JSON from the note card. And we think that's a pretty powerful way of actually working with a cellular device. Now, the note card is an awesome little module that's ready to use, that's easy to use and ready for any product. Many developers, however, aren't looking to spin a board with an M.2 connector for a prototype. So in addition to the note card, we have a number of carrier boards, which we call note carriers, that help you get started using the note card. And there's 3 types of note carriers that I'll discuss today. First is the note carrier AF, which is meant to be used with one of the 50+ Adafruit Feather MCUs on the market today. The AF includes a Feather socket, 3 I2C ports for plugging in external peripherals, LiPo and solar panel JST connectors, and onboard cellular and GPS GNSS antennas. It also includes a micro USB port for power and USB serial access to the note card. Next, we have the Note Carrier Pi, which is perfect for adding the note card to single board computer projects. It also includes a Grove I2C port for external peripherals, a Raspberry Pi compatible and stackable 40-pin header, and a micro USB port for USB serial access to the note card. Finally, we have the Note Carrier A series of boards. Now, there's actually 3 variants to the A, but all 3 have onboard cellular and GPS antenna, as well as a micro USB port for power and USB serial note card access. Beyond that, there are some slight variants. The AL, I'll show you these actually up close here in a moment, provides LiPo and solar JST connectors for building solar-powered solutions. The AA provides a 3 AA battery pack on the reverse of the note carrier for traditional battery-powered applications. And the AE is a bare board with castellated edges that can be soldered directly onto a custom PCB if you need to incorporate the note card and note carrier directly into an end product. But regardless of the note card and the note carrier you choose, another powerful feature of the note card is that it works with any microcontroller or single board computer and with any language. You can talk to the note card from high-end single board computers all the way down to 8-bit MCUs like an Arduino Uno. And the note card works with any language that can output and read strings. We provide libraries and samples for Arduino, C, C++, and Python, and samples for a ton of different development boards, single board computers, and MCUs. So the next demo I want to show you is I actually want to show that in action, this concept of bringing your own board and language so that you can see it across 2 different development boards and languages. And so for here, what I'm going to do is I'm going to stop sharing my screen briefly because I want to switch my webcam to show you what's happening on my desktop here. All right. So very briefly, I want to actually show you, and hopefully this will autofocus well. On my desk here on this carrier, I have, this is the Note Carrier AF that's sitting right here on the top. The Note Carrier AF, as I mentioned, has a native root feather port, JST connectors, a couple of I2C connectors, and a STEM QT connector for connecting other external I2C devices. So this is a pretty powerful developer-focused board for just plugging in a feather, plugging in some sensors, and going off to the races. Now, I will show you sort of in addition, this is the Note Carrier AL. So you'll notice this is the one that has the LiPo battery connectors, LiPo and solar. There is a set of female headers on the top that bring out the note card pins so that you can connect that via jumper wires directly to a product or to a project. This is the Note Carrier AE, and I apologize that my autofocus isn't happening here this morning. This is a Note Carrier AE. You'll notice it is the same base PCB, but a lot of the features have not been populated because this is meant to, again, be soldered into a project via the castellated edges once you plug in a note card. But there is still a USB micro port there for connecting over serial. And then finally, this is the Note Carrier Pi. So Note Carrier Pi has the 40-pin header for popping just on top of a Raspberry Pi or any single board computer that has that 40-pin Raspberry Pi pinout. And then there's also male headers on the top, so you can stack another device on top of that as well. And there's an I2C port. So that is a quick look at the various types of devices. But when I get into the demo here, one of the things that I want to show you is using a couple of different devices. So you'll notice that the couple of peripherals that I have here, one of these is a BME 680 temperature, humidity, pressure, and gas sensor. And the other is basically just a strip of neopixels or a strip of an LED strip. Both of these are daisy chained in to this connector and connected to the note card over an I2C bus. So I have a couple of different feather boards here that I'm going to demo. One that will run one ESP32 that runs Arduino and the other that is running CircuitPython, so you can sort of see the differences between these 2 environments. So I'm going to plug in the ESP32, and then I'm going to go back to my desktop. So go back to sharing. And with my ESP32, what I've created is just a quick sketch that reads from the temperature and humidity sensor and sends that to the node card. And what I'm using in the Arduino environment is our Arduino library. So again, in our dev site, we have a number of different libraries that are already ready to go for Arduino, Python, C, C++, and Go, as well as a number of samples for ST boards, for Nordic NRF52840, the TI MSP430, and then generic ARM embed OS devices as well. And so you can download any of these SDKs from there. The Arduino library can be installed via the Arduino IDE. But once I have that in place, there's really two key pieces. One is I have a node card object that I can talk to. This is how I send requests and read responses. And then inside the Arduino ecosystem, again, because this is all JSON, all I'm doing is building up JSON strings and sending those to the node card. Now, the way that we facilitate this is using a library called J that we distribute with our libraries. And it just makes it easy in C and C++ to create JSON objects that can be sent to the node card. But I'm doing the same hub.set command that you saw me do before using the node card playground, setting a product UID, and then setting a few other attributes so that my device can actually sync in a period and do some other things that I want it to do. And then I send that request to the node card. And that is effectively the same as what you saw me do, except I'm doing it here programmatically in my application. And then as I skip below to some other things that I'll show off in the next demo, once I actually perform a reading, and I'm doing this every 60 seconds or so, once I perform a reading, let me actually open up my serial monitor here. I'll bring that over in a second. Once I perform a reading, then I'm actually doing a note.add, right? Similar to what you saw me do before in the CLI, I'm adding an individual note. I'm setting the temperature and humidity values as well as some other things, and then I'm sending that off to the node card and I'm getting a response. So with this actually running on my device, once I plugged it in, you'll see this is what my note.add looks like. And let me actually go ahead and clear this, and I'll reset so that you can actually see what happens here. You'll see my hub.set. This is the same. It's outputting in debug mode, the same command that I just walked you through. Here's my hub.set, setting that same product. And then each of my note adds here below, you'll see I'm getting a temperature of 24.63 degrees Fahrenheit. Thankfully, it is not that cold in here. So, excuse me, that's Celsius. Thankfully, it's not that cold Fahrenheit. And then the humidity, and then I get a response from the note card that there's one note queued and ready to go. So that's the Arduino. That is my Arduino example there. Now, what I'm going to do now, and I'll do this off screen so that I don't have the lag in switching, is I'm going to unplug my ESP32, and I'm going to plug in an Adafruit Feather M4 Express. This is still a Feather device, but it's a device that can run CircuitPython. So I mentioned earlier that we do have support for Python. There's an entire Python, I have a Python library. That Python library supports Python on the Raspberry Pi, Python on the desktop, as well as Python via the CircuitPython library. So once my device is plugged in, what I'm going to do is I'm actually going to open up the Python file so that you can see what that looks like here. And you'll see, even if you're not familiar with Python, the language, even if you don't like Python, the language, it's the same sort of construct. I'm pulling in the library. I'm setting the product UID. I'm making a connection to the node card, in this case, opening an I2C connection, sending in my hub.set, and then periodically sending in my sensor readings. And in this case, doing it every 15 seconds. Now, if I open the serial monitor on this device, you'll see a very similar set of commands repeated. Oh, I made a mistake. One moment. As I go back, pull that open again. Did a reset instead of save. So let me open my serial monitor back up on that device on the M4 Express. Now, when I save in CircuitPython, it will reset the device. You'll see the same thing that you saw in the Arduino serial terminal. I'm setting the device with hub.set and then passing in each of those individual notes to the node card. So all I had to do was use the library, but even in the absence of a library, it's possible to just send strings over serial to the node card. It's a really really easy, really powerful construct to use. So let me switch back to my slides. All right. Now, for the last piece, I want to talk about NoteHub. Because IoT solutions start with sensors and hardware, but they rarely end there. After all, there's really little point in adding connectivity to a product if you're not going to leverage that connectivity to gain insight and control your product. And in the Blues wireless ecosystem, NoteHub is the secure conduit for device-to-cloud connectivity through the Notecard. NoteHub is a secure device console that gives you the tools to manage a single device or a number of devices and fleets. Devices are auto-provisioned using a secure VPN tunnel once you add a valid product UID, which I showed in the demo earlier. The Notehub actually enables bidirectional communication with the Notecard, as well as the propagation of device, fleet, and project settings through environment variables. And through your device console, you can monitor events, sessions, as well as the onboard temp and voltage settings on the Notecard. And finally, the NoteHub provides a facility for performing OTA, over-the-air firmware updates to the Notecard firmware, as well as the connected host MCU through the Notecard API. So there are a lot of, this is obviously a very challenging environment because we allow you to bring your own host. But if you're working with an STM32 microcontroller or an NRF52840 or even an ESP32, there are facilities for actually self-updating firmware using over-the-air firmware update capabilities. And the NoteHub and the Notecard actually provide a series of APIs and features that allow you to perform host firmware updates in addition to updating the firmware on the Notecard itself. And that's pretty powerful, we think. The NoteHub allows you to route your project data to any cloud application. We provide built-in routes for major cloud providers, as well as support for routing to HTTP and MQTT endpoints. And to ensure that you're only transferring the data you need into your cloud apps, we also provide a series of built-in data transformations, as well as support for JSON-ATA, a sophisticated transformation language for JSON data. So we recognize that you don't necessarily want to route everything to your cloud services. So we give you the ability within NoteHub to tune the payloads down to exactly what you need for your external or for your third-party cloud application. Now, for the last demo today, I want to show off the bidirectional capabilities of the Notecard when used with the NoteHub and the process of creating routes to third-party services. So let's take a look at those now. And I'm going to unplug my Circuit Python device. I'm going to plug my ESP32 back in. And a few things that I skipped over earlier that are relevant here. I did show you that I had an LED strip that was hooked back up. And so what I have done now is I've also added the ability to get inbound messages from the NoteHub. So my Notecard can actually receive messages from the NoteHub, and if there is a certain kind of file that shows up, I can take action and actually turn on the LED strip that's on my device. And so I showed earlier in the animation, the way that inbound notes work is exactly the same as adding messages to the Notecard to send it to NoteHub. I'm basically just sending some sort of JSON object to the Notecard, and then the Notecard is letting the host know that the device is ready to take action. Now, there's actually a few ways that a host can accomplish doing this. You can poll the Notecard repeatedly to see if, hey, is there any new information for me to act on? But we also provide the ability to basically wire a GPIO pin on any device to the Notecard, and then fire a pin, the attention pin, to basically let the host know, hey, I need to interrupt what you're doing. There's something happening that you need to take action on. And so what I've also added into my Arduino application is the ability to do an interrupt service routine that fires anytime the Notecard pulls that attention pin to a place where I need to be notified. And so the way that you do that is with a card.attention request. Again, using that same noun verb semantic in our API, you're basically telling the Notecard, I want you to let me know when a file called color.qi shows up. Let me, the ESP32, I want you to let me know when that happens. And when that happens, fire an interrupt. And when that interrupt is fired, what my host will do is get that note, get that actual message or note from the note file, and determine, okay, did the person send in the color value? Okay, if they send in the color value, say the color has changed, and turn on the LED strip. So before I show you what that looks like, I'm going to go actually over to the Note Hub and give you a bit of a look of what Note Hub actually looks like. Now, when you first create a Note Hub account, and this is the project, this is will be your first step before claiming the note card or adding a product UID to your note card. You'll come to notehub.io and you'll see a list of projects. As you create your first project, you'll be prompted to give it a name and a product UID. And once you've done that, you'll be able to actually add devices to that product. In my case, I have my Dallas IoT demo product, and I have one device here. It was last seen a minute ago. So I can actually get information about my device. I can see what its temperature and voltage readings over time have been. I can get information about how it's being used, the number of bytes that have been used over the amount that I actually have in my plan, get information about the state of the device, the last set of JSON objects that came across. Again, the note card sends JSON, more than just the JSON that you provide. There's a lot of information about the tower location, about sessions, about individual data points, etc. There's really a ton of good stuff here. There's a lot I can see about my device, but I can also take a look at all of the events that have come in. So, right, I showed you earlier that I'm actually capturing humidity and temperature, and those are showing up in my dashboard. I can click on an individual event and I can see the location where the event occurred. If I'm using GPS, I'll see the actual device location as well. And then I can get information. I can see the body that I sent along, as well as the full JSON object that came, including the tower information about where that event actually came from. So the way that I talk back to the note card is I can either use the Note Hub API via curl or via another UI command or UI tool, or I can actually select a device and I can say add note. Now what I'm going to do here is I'm going to add a note called color.qi, and it's going to be, I'm going to call it LED color. And I'm going to set the color to blue so that I don't blind anybody. These lights are really bright. Now, before I click enter on this, I'm going to switch back. I'm going to stop sharing my screen, and I'm going to show my desktop, because this might happen. We'll see now that I've said it. It probably won't happen immediately. But I'm going to reshare my webcam. I'm going to hit add note. And what's happening behind the scenes is the note card is informing, or the Note Hub is informing the note card that I've got a new message in, and then it informed my host, and you'll see the blue lights came on pretty quickly. So again, it's important to know that this is a bi-directional system that's intended to work, not just getting data from devices, but if your application calls for it, allowing you to actually control actuators and interact with your device whenever you need to from within your cloud application, from within Note Hub as well. So let me go back to sharing my desktop. And the next thing that I want to show you is actually the routing piece of this, because again, we recognize so many third-party, many of you, if you're building an IoT application, you already have a third-party cloud. You already have a service out there. You're already using Azure, GCP, AWS, something along those lines, and you just want to get your data into that service so you can build your dashboards and do all those kinds of things. And so we provide that through a routing capability inside of Notecard as well. And in our dev site, we have a number of tutorials that walk you through configuring AWS, Azure, initial state, and ThingSpeak. And I'm going to use initial state today because it's a very simple way of showing what easy dashboards can look like. But the essential idea when you're building a route is that you're going to create a connection, some sort of secure connection between the Note Hub and your third-party service. In the case of initial state, what this looks like is that I'm creating a device provisioning route. And as you create a new route, you'll see there's a lot of different options for AWS, GCP, AT&T data flow, the ThingWorks API, MQTT. We provide a lot of canned options here. But you also have a generic HTTP and HTTPS response route type as well. And as you create a route, you're specifying whatever headers the third-party service requires, an ultimate URL, and then you specify, what sort of note files, if you have fleets, the fleets that you want this route to apply to, and then you can perform some sort of transformation. We have some canned transformations, or you can do JSON-nada. And this route is a provisioning route. Basically, what happens here with initial state is every time a new session starts, just when a session starts, which is not every time the Node Hub syncs, or the Node card syncs data from the Node card to the Node Hub, but every time a new session begins, it's going to fire off a request to initial state saying, hey, if this device doesn't exist yet, add a bucket for it. And the bucket is initial state's concept for a device, a set of device data. And so I fire this event once.
You may need to reshare your desktop real quick.
Resharing.
Yeah, that's much better.
Okay, great. All right. Apologies. So I've been mostly on this screen, and really all I was talking about was just the process of creating individual routes. This is a route that happens every time, or this route, provisioning route, happens once per session. But then when I go to create the actual data route, again, I'm choosing an HTTP, HTTPS response. It'll depend based on what your actual cloud service is. And I'm adding some additional headers, including my access key, bucket key, etc. And then in this case, what I'm doing is I'm choosing just my note files. I didn't cover this specifically, but when I'm adding sensor data in my Arduino application, I'm actually specifying, let me go up, that the note file is sensors.qo. This is a way for me to just say similar data, all the same kind of data is in this file. And so I'm only going to take things from this file and send those out to initial state. And in order to do that, the transformation I'm doing is just flatten body keys values. I'm just taking everything in the body and I'm just sending it as key value pairs over to initial state. And what that allows me to do with initial state is build a simple dashboard like this. I'm able to create tiles that show the current temperature, temperature over time, and then some additional values like the language that the device, that the data came from, or the current LED color, right? And this updates pretty quickly. If I were to go back and actually turn the LED off via Node Hub, which I can do that real quick. Click Add Note, and I'll do the same thing that I did before. Add Note. That'll propagate down to the device, and then when the next time that a note add happens, that'll actually show up here in initial state as well. That'll take a little bit longer because it's what it's effectively doing is coming down to the device and coming back around. But really the specifics of how initial state works is not as relevant here as just understanding that the whole point of routing is to allow you to very quickly get your data into the third-party applications that matter to you, into the places that are really, really most important. So with that, Mobeen mentioned this already, but we are launching soon. We are days away from launching. Please keep an eye on blues.io for a new website and news about our launch. There's going to be new information coming in just in mere days. And feel free to email me. Mobeen shared his email address earlier, mobeen.con@blues.com. I am at bsatram@blues.com. Drop either one of us an email if you want to be notified when we're live, because we would love to hear from you and hear more about what you'd like to build and what questions you have. So given that, I did get it, squeak it in right under 45 minutes. So I'm happy to spend the rest of our time doing Q&A, answering any questions or what have you. I'll take questions, concerns, and snide remarks. I'm fine with all of those. So I'll let the room go if there's any, but I'll also check the chat.
All right. Any questions in the room?
I have questions.
Yeah, somebody speak up. Just
Bunch of technical questions. Is there a way to use the custom hub, not your hub?
That is a great question, and there is. We actually provide an open source version of our Node Hub that you can use. Now, it does not have all of the features of our SaaS service, but in terms of secure connections, routing event data, etc., we do have an open source version that you can use as well. And we provide APIs that allow you to connect to that version instead of ours.
Yeah. Okay, we're live. Any other questions?
I have more.
I have tons too, so I don't want to hog the mic either. Let me ask probably the most important question. I want this in my hand today. How can I get it, and what's the fastest way I can get one of these in my hands?
Yeah, is everybody else listening to this also? Or?
Yeah, they can hear you.
So as Brandon said, it's days before we launch.
Okay.
But you can go to blues.io today and just play around with the documentation and stuff. There's a web REPL there that you could use for remote controlling a note card. But in terms of actually getting a note card, please contact Brandon or myself, and we'll try to get you a unit out. But the site will be open for self-serving in days. But if you want to right now, right this second, just reach out to us and we'll make that.
Consider this reaching.
Yeah. I got it. I brought one with me. But
All right, we do have a question in from the chat that says, so device management, is it through a third-party application?
Great question. No, we have built the device management services ourselves, and they run in our own private cloud.
So, are you planning to allow to write applications to run directly on the note card, or are you planning to always require a host?
That's a great question. There's two, I'll give you sort of two-part answers. There actually is a way to use the note card without a host. And so, for example, we have customers that are looking at building asset trackers, and there's enough on the note card itself that as long as you can provide power to it through like a note carrier AL, you could use it as a standalone asset tracker. What you would do in that case is that you would just pre-configure some of those API requests that I specified earlier. And we provide an ability through our command line tool to actually send a JSON file that has a handful of commands. And so you can do all of the requests to set the product UID, configure it as a tracker, step 3, 4, and 5. And then now you have a device that doesn't need a host. You provide battery, it's connected, and you're off to the races. So we do provide some headless style support for those types of use cases. But beyond that, when it comes to having direct developer access to the MCU that's on the note card, we don't currently provide that to anyone. I don't think we have any plans to.
Any other questions?
Do you have longevity plans? Like if the company goes out of business, can you guarantee that the thing will work for 10 years?
Sounds like a good question for Mobeen.
company is well funded. Of course, we can go out of business. That happens. It can happen. But the card, when you put it in something, it comes with a certain amount of data. The first versions are 0.5 gig of data for 10 years. So once it's provisioned in the network, it's provisioned. It's we don't turn them off. You can use it or toss it in the bin. It's just use it or lose it kind of data. So for 10 years, yes.
So you have an agreement with carriers
Yes.
for 10 years.
Yes,
guaranteed.
that is correct.
And that's with AT&T,
That is correct.
and this has come up.
About AT&T connectivity for 10 years.
Yeah, I don't want.
And so one of the things that I've run into recently is that as provisioning platforms change on the SIM cards and as back-end infrastructure, which will evolve over the next 5 years, are the agreements in place for all of that to stay for a period of 10 years? Because it's recently happened to me, the negative, right?
I was there. We have abstracted that out for customers.
Okay.
The idea here is that once you provision it, it's provisioned.
Okay.
The network. So it doesn't matter if the provisioning platforms change, the device itself is provisioned in the network. And it's for the devices that are global, it's enabled in the roaming networks with 135 countries with 400 different carriers. So it's.
So I'm understanding these are sold, quote unquote, pre-provisioned to that degree. Got it.
Now you can run out of data.
Oh, absolutely.
Right. So if you run out of data, you can add data to it. You can buy a bucket of data and say, okay, I need another 0.5 gig on the same device. That bucket of data will then need to get provisioned in the network at that time.
I have another one. So on your backside SaaS portal, are you currently setting up tiers or service plans where you're rate limited, or is there free access for a certain rate? Or so can you tell us a little bit about
there
that?
are service plans just like any other SaaS offer. There is a free plan with limited amount of notes or messages that you can use and how many people can be on a project. And then that goes to a developer tier, which is very simple, and then enterprise tiers for deployment. So the whole product, as you can see, is very developer centric and
Oh, yeah.
developer friendly. So the idea is we want thousands of flowers to bloom and very easy for people to develop on these SaaS plans. Really, the places where a lot of customers will need SaaS plans around support and all of the other stuff, and that comes in the later tiers.
Looking for a PCMCIA version for my.
I know what that is.
That stands for People Can't Memorize Industry Acronym.
I just tried to go to your website, blueswireless.com.
No, it's blues.io, and it's a single page today. Wait, and if you want to look at the developer tools that Brandon was talking about, is dev.blues.io, and so you can see a lot of that there. But the website will go live. You guys are the early preview audience here.
Any more?
Good.
There's a few in the chat.
What is the overhead of using, sorry, we're not listening to you, Brendan, you muted. What is the overhead of using JSON?
Yeah, what's the system engineering in terms of the payload?
Yeah. That's it. And we get good.
Yeah, so
But the
Hang on, Brandon.
Yeah, hang on.
am I unmuted now? Okay. That's a good question. There obviously, obviously there's a trade-off between convenience and size. And so when you're sending notes infrequently, there's not really much of a concern over how that overhead compares. And so if you're doing more frequent sending larger volumes of data, we actually provide a capability to create templates of similar notes that effectively pack down the size to where the way that the notes are actually stored internally and sent to the Note Hub are not actually JSON objects, so you're not paying that performance overhead. If you're using a template, which is just the same, like what I was doing with temperature and humidity, I could use that as a template. I could store a lot more notes and send them a lot more efficiently without really having that overhead. I get the benefit of having the developer friendliness of JSON on the inbound and on the outbound side, but it's not stored internally that way. So there are options to improve what that looks like. I did want to cover, there's a couple of
You may
things.
want to talk about, you may also want to talk about the metadata that comes with it.
Yeah, so I showed this off a little bit in Note Hub, but there is also, you know, a lot of data that comes along for the ride, which is really useful, like tower location. If you have GPS tracking on device location, I showed the temperature and humidity graph. You're getting not temperature, humidity, device temperature and voltage. So you always have a view of what the current voltage state of the device is, which can be really helpful in a field set of environments. So there's a lot of useful metadata that we sort of include for free as a part of what of using with the note card. Is like, I had to take water and mute myself for a second.
So
Anything else in the room?
what is the price of the device?
$49 for the base device in the US.
Also, it's device and the plan for $49.
Yeah, it's included in that. And then the global device is $59.
Yep.
So I was tinkering with Helium in San Francisco and Sigfox. It seems like those networks are more regionalized based upon the frequency allocation. So this is, I guess the real benefit here is global.
Yeah, this is standard GSMA cellular.
Yep.
NB-IoT, Cat-M, Cat-1, you know, offered by all the carriers around.
With a maker market kind of price, which is great.
Amazing.
Yeah.
So in the US, you're partnered up with one.
We are partnered up with AT&T.
So no plans to go agnostic. I mean, you're with
Yeah, we
that.
partnered up with.
Yeah.
Like the iPhone.
Well, it's pre-provisioned and packaged, so it has to be, right? Yeah. Anything else in the room?
Let's thank our speakers, Naveen and Andy. The guys online, don't leave. Gary Ramsey is going to take over hosting in a few moments, and Brandon's going to hang on, right? And be there for 30, 45 minutes, however long the Q&A goes online.
I'm typing a couple of answers, but I'll go ahead and as folks ask a few other questions, I'll I'll go ahead and answer them personally. So the next question I was going to answer was Bruce Hubert asked, in the tracker scenario, does the board automatically switch between networks as it moves? It depends. One thing it's important to understand is that right now the note card is a bit, or the note card is the cellular modems that we get from QuickTel are tied to a geo. So North America, Europe, global are sort of the three variants that we have, and there's narrowband and wideband for each of those. When you're in those regions, the device would switch automatically between countries. When you go from Canada to the US to Mexico, what have you. Globally with narrowband, you would obviously be able to switch to any supported country. And our support is based on the countries that AT&T has support for, so it's currently around 135 countries. So you will automatically switch, but if you're using one of the wideband devices, those are tied more to a geo, so you couldn't necessarily go from the US to Europe without switching the note card in that case. DP Prakash, what's the support plan if the note card device breaks down within 10 years? If the physical hardware actually breaks down? That is a great question that I'm going to have to follow up with you on to give you sort of the specific company policy on that. I will say in the short term, because we are still so early, that if you have a device from us and you ever have any issues with us, then email one of us and we will take care of it for sure. But in terms of like what our long-term plan is, we're still in the process of defining a lot of those terms and conditions around the hardware. And I don't want to, because I'm not a lawyer, I don't want to speak out of turn, but I will say as you visit our dev site, check out our hardware data sheets, which are up there, and those terms and conditions will be in those data sheets as well. So they'll be able to speak more coherently than I can. Chris asked, can you talk a little about network debugging, TLS on, TLS off? Chris, that'd be helpful. Can you give me a little bit more info there on what exactly you mean?
Sure. Can you hear me okay, Chris Kendrick?
Yeah.
Oh, absolutely. Great. Oh, yeah. So I was just curious about your secure tunnels, because typically when you have a tunnel for security purposes, it's really hard to talk to a network provider of how the device is functioning when the tunnel is on versus when the tunnel is off. So I'm just curious if have you thought it through a little bit about when you turn TLS on for tunneling and encryption, how you can actually manage the device? And for example, who do you call when your devices aren't working on the network? Of course, you don't go back to Blues. You probably have to talk to a service provider. So I was just thinking, TLS on, TLS off, how to turn it off, how to debug once you deploy. Does that make sense?
Yeah, it does. So I will give you, Chris, I'll tell you what I can, and then I'll ask that you follow up with me over email, because I know that our head of engineering probably has a little bit more insight than he can provide than I can in terms of functionally how a lot of our tunneling works. But I can tell you that we, as a part of our provisioning handshake process, we do have a secure connection into AT&T's networks for actually activating the SIMs and making sure that those sessions are actually being handled securely. But in terms of what the end user is offered for making sure that TLS and non-TLS sessions can be debugged, you have the ability when you're creating from your host firmware, when you're creating notes and note files, to specify those as secure encrypted note files versus plain text note files. And so you do have the ability there on the firmware side, but at the present it does require you to make a host firmware change. So I'm not sure that it would give you a ton if you're actually looking at debugging the network. So I'm going to end it there and say, shoot me an email at bsatram@blues.com, and I'll see if I can give you a little bit more insight, because it's a good question. Make sure.
Super. And just the last question is, all of the components are from a U.S. friendly companies. I work in the DoD and FAA environment, so we have to make sure that all the components are from friendlies.
Yes, yes. And if you want to, again, like include that in an email, I can provide you specific details for that as
Perfect.
well.
Thank you. Super.
Sure.
Thanks, Brendan.
Brandon, this is DP Prakash from Ethiopian.
Hey, DP.
Thanks for the nice presentation. So one question I wanted to ask you, this is an exciting breakthrough, and long been a fan of Ray Ozzie, with his Lotus Notes invention at IBM. I was at IBM for 17 years. So his impact is very real with his work on Azure pioneering work. So this is great. So he's on to something here. Great team, people like you, Pawan, you folks are leading great work here. My question is, what have you learned from the practical applications? In theory, this should work, right? But as you start like scaling this up with multiple different industries and so on, what have you learned in the recent time that surprised you?
Oh, DP, that's such a great question. It's a very open-ended one, and I love it. I will tell you that Ray, I would love one of these. Let's get Ray on in the future, because I'd love to hear him answer that after like 2+ years. But I can tell you what I have learned, and I touched on this a little bit in my presentation, is that concept of guardrails, of too many or too few guardrails, seems to be the thing that really stops a lot of prototypes from getting off the ground, and therefore keeps pilots from actually happening in a lot of industries. I shared CircuitPython as an example in one of the demos, not because I think that CircuitPython is a hardened industrial ready language for building IoT solutions, but to show just that you're not constrained when it comes to choosing your host microcontroller or microprocessor. And I think that one of the things that we have learned is that customers really like that idea of being able to sort of build their own set of devices around the note card. We take care of the radio and the connectivity piece of things, and they don't necessarily want us to take care of the rest. They don't necessarily want us to say, oh, and you have to use a Nordic NRF52840, or oh, you have to use C as your primary programming language, and you have to use this developer tool chain and what have you. That's been really interesting to see. And I like seeing that, because it's sort of how I felt as a developer for years. The other thing that's been really interesting we've seen is a lot of customers have looked at the note card, and we've seen it as sort of like, hey, start your pilot, start your brand new greenfield application with this. But we've had a lot of customers that have come through the door that have said, oh, actually, we want to retrofit an existing thing. Like, we think this is good enough to just take and do a minor change to our existing PCB to get this in, and we'll do a retrofit as opposed to a brand new greenfield application. And I think that's been a bit of a pleasant surprise to us as well, is that we built something that is flexible enough that you're not having to completely respin a brand new solution from the ground up in order to work with a note card. So hopefully that answers the question, DP.
No, that's great. That's great. That's the kind of insight looking for. You're a learning organization. So as you scale, because it's new, right? There are things that that we could learn. And hopefully, after you answer some questions, if there's time, please also address the question about security. Now, you mentioned it briefly, but I'd like to understand if some of the stuff that we are building require like extremely high security, and in terms of ability for hackers to get through. Some comments on that towards the end would be good.
Yeah, definitely. I can actually address that now. I mean, one of the things, and I touched on it briefly, but probably could spend a bit more time on it in the future. But it is, I think, one of the benefits of being in, building on top of a cellular IoT solution is that you are from the start functioning, quote unquote, off the internet. And so our communication is basically, on AT&T's private networks into our VPN. And so really everything is secured from the point of when you put data into the note card to the point to where it actually gets into the note hub. And then from that point, it really depends on you in terms of if you're routing data out, what your service looks like on the other end and what your tool chain looks like. But one of the things that I do like about the routing capability is that if you have a key set that allows you to connect securely to Azure, to AWS, is that you're not storing those keys in your host firmware, so that physical access to the device doesn't put your third-party cloud applications at risk. And there's a whole lot more, DP, that we can talk about around security. There's going to be a lot more content that we have coming.
That's really cool. Thanks.
Yeah, appreciate it. Good questions. And I'm always available. I will say, shoot me an email at bsaturateBlues.com. We also have a developer forum that is up and coming. You'll be able to link to that from dev.blues.io if you have any other questions. But I'm always available to ask anything that comes up later.
Brandon, when is the public announcement going to be? You said in a few days, right? Do you know
Yes.
roughly what date it is?
Days. I can't say specifically yet, other than to say like we're frantically trying to put the fit and finish on the last few things on the marketing site and a few other pieces on the NoteHub side. But within the next several days, we'll
Okay.
we'll
Got it. Thanks. Exciting.
Yeah, it's been a long road. I mean, I've only been working on it for 6 months, but for Ray and a few of the other early employees, it's been 1.5 2 years, 2+ years. So we're all very excited to get this out there and start getting some feedback and people using it.
All right. Any other questions at this point?
So I'm not sure. What about your product? Do you think they are compatible with blockchain if I want to apply that to use on blockchain?
Thanks, May. It's nice to meet you. Thanks for introducing yourself. That's exciting. And I can tell you, I am not very savvy in the blockchain, in the distributed ledger transaction technology space. But I would love to hear more about what it is you're building, because the Notecard is fundamentally just a radio that allows you to backhaul your critical data bidirectionally. I can't imagine that blockchain would not be something that's at least worth exploring. I say the same thing when I talk to folks that do machine learning or AI work, provided you're not trying to do, cloud backhaul of live streaming video. The Notecard is a good solution for doing on-device inferencing and then sending those results back. And I think with blockchain, it could be, depending on where you're doing your compute, if it's in the cloud or if it's at the edge, it could be an interesting thing worth exploring. So feel free to shoot me an email, dsatcham@blues.com, and I'd love to chat more.
Okay, thank you.
Yeah, thank you.
Jim, you want to go ahead? There you go. You want to go ahead and introduce yourself, Jim?
Yeah, thanks. Hey, Brandon and all. This is Jim Extroth from RTP in North Carolina. And I and my partners are working on a startup. Basically, our use case is to add IoT instrumentation in senior residential facilities to enhance the safety and wireless of the residents. And this fits in very nicely what we're trying to do on our kind of rush to get into pilot facilities once we get past this pandemic situation. So very timely. Appreciate it very much.
Great to hear from you, Jim. I've known Jim for a while, what, 3+ years now? So
yeah, a couple iterations. Yeah. We continue on. We're inching ahead. So
that's great.
Glad to see what Blues is doing these days. This is fantastic.
Thanks.
All right, Chris, it looks like your mic just went hot. Did you want to say something?
Oh yeah, this is Chris Kendrick. I work for OST Global. We are a systems integrator for the DoD and for other government agencies, sometimes private, sometimes government. We're really interested in this technology because we get the requests all the time for creating smart environments for the FAA and for smart city deployments. And one of the, and I come from a smart city background. I worked with Mobeen at our previous company. So we really are aware of some of those technology issues, getting data, up to the cloud, single point of failure, et cetera. Those are huge issues. So we're really interested in the application, solving the issue of getting data into the cloud seamlessly, easily, with security, et cetera. So I think you folks are spot on, and we look forward to working with you, with our team. So I have one question. That nice little breadboard that you had there, Brendan, can we get a parts list of that? That would be great, to kind of jumpstart all this, to get that parts list, right?
Yeah, Chris, shoot me an email, but I'm happy. So the company that makes this little platform that I have my stuff on is called PhaseDoc. I'll go ahead and actually share my screen again. They're actually or change my webcam. They're a startup that's actually based in North Carolina that I advise, and they create these little prototyping platforms that actually allow you to basically just connect any device to it. So they have some cool stuff out there, but I use this thing. It's great for travel, but it's also great for organizing everything. And I know that's not a very clear view of things, but this thing's called the Workbench. Company's called FaceDoc. So I love this thing. I'm glad you asked about it. They're a great company. And it's
Yeah,
nice.
if we could get a parts list, I'll reach out to you. But for the broader team, some kudos to them to helping us, rapidly develop. That's the whole key, right?
Oh, yeah, definitely.
All right. I'm going to apologize up front if I butcher this, but is it Francis?
Good morning, it's Francois.
Ah,
I'm with Evixia Telehealth. We've been using Blues for about, 6 months now. And we've built a remote patient monitoring system, bidirectional, that's really dealing with, I'm based in the US Virgin Islands, and it's really taking advantage of the ability of Blues to do the function in a unreliable or disconnected model. We lose power, we lose internet access, the device get abused any other way. I must say it's been, we've tried with LoRa for about 6 months and finally gave up, switched to Blues, and we are now in the first phase of clinical testing. And the issue is not with Blues, it's with the medical devices that we get from third parties at this stage.
Francois, it's great to hear your voice after so many chat conversations. Thanks for coming this morning.
Thank you for your support.
Yeah.
Hi, folks. Is one other question. I was just asked by a team member who couldn't join if this is being recorded.
yes, it is going to be recorded, and Ed sends this out usually a couple of days after. He'll do a little post-production and so forth. So yes, it will be available. So if you're getting an email indicating that this is the third Friday IoT breakfast, then you should also receive the email with the link. Does that answer your question?
Sure does. Thank you.
We also had a question here. FaceDoc is also available on DigiKey 2.
Oh yeah, thank you, Jim, for mentioning that. I think it was a follow-up to my mention of FaceDoc, but yeah, their stuff is available on DigiKey as well. So, Chris, that was your question. I'll definitely follow up with you on sort of what components I'm using for prototyping. So stuff.
Thank you. Yeah.
All right, Brandon, any last comments?
No, just thank you all for putting this together, and thank everybody for coming. Please again follow up with me over email with anything, and excited to hear your experiences working with the Notecard.
And share your email one more time.
BSatrom, SATROM @blues.com.
Fantastic. All right. Well, if we don't have any additional questions, we'll conclude the meeting. Again, thank you, Brandon, for your time today and dedicating that couple hours just right here. And I'm sure there was a lot of prep time behind that. So we really do appreciate that on behalf of the IoT breakfast / IoT Texas special interest group. Again, thank you everyone for participating today, and we look forward to seeing you on the next third Friday of the month. Have a great day.
All right. Take care, y'all. Thanks, Gary.